I am Anil Kumar. Welcome to my class with Akshit. Immediately after the mock test on derivative power rule, we are on the product rule. We'll discuss product and quotient rule in this particular video. The derivative for the product rule is given in the books and is shown here. You can look into this, try to understand, and if there is a difficulty, write an email to me. We can discuss it further. Our approach, engaging minds, helps students think creatively and solve problems strategically. It helps them to connect with the context, visualize strategies, apply learnings, and bridge the gaps. Join Anil Kumar classes, gain confidence, and get ready for future. We develop mathematical and social skills for excellent performance of our students. The gift of education. I can be part of your success story, build strong foundation, ensure bright future. Join Anil Kumar classes, send an email on the address given here. Let us now enjoy the class with the student Akshit.
Now, can you summarize your learnings from the mock test which we just had?
Yes, sir, for sure. So we didn't even start derivatives yet in school, and I'm actually really happy that I was able to answer the entire practice test. So I think that when the actual test does come, I'd be able to do it really fast and really accurate, of course, because right now I have back-to-back practice, right? So I think that'll really help me during the test.
Correct. Beautiful. These questions were actually from previous test papers, and therefore you expect a similar test paper. And I'm very glad that in half the time you did most of the things, right? Perfect.
Yeah.
Okay, so now let's begin with a new chapter. The new chapter for you is to extend the derivatives to product rule and the quotient rule. So
Yeah.
I'll just share with you blank screen, whiteboard, and then teach you both the rules. Is that okay? Okay, so there we go. We have learned few rules so far. Let me just summarize what we have learned. If I have a function which is a constant, then the derivative of this constant is what? Zero,
It's K.
because constants do not change, right?
Right.
K is a
Right.
constant. But if I have the function which is x to the power of n, in that case, the derivative is what? N times
And
x to the
X
power of n
and
minus
minus 1.
1. If I multiply this with some constant k and then do x to the power of n, then what is the derivative? Well, in that case, the constant gets multiplied with the derivative of function, which is n x to the power of n minus 1. Correct?
Yes, sir.
You also learn that the sum and difference rules, right? So if I want to find, if there are two functions, let us say f of x plus g of x or minus g of x, correct? And if you have to find the derivative of this, in that case, you can add their derivatives. You get the idea,
Yes, sir.
right? So the derivatives will be what? Derivatives will be f derivative plus g derivative, right? So you can add the derivative and get the result. So all these rules so far we have learned, we applied some of them, and also you know the difference quotient rule, which we learned first principle, which was that the derivative of the function is basically written as limit h approaches 0 for f of x plus h minus f of x over h, correct? So that is your difference quotient rule. So all this we know so far, correct?
Yes, sir. Correct.
Now, let's move on and learn two more rules. And that is, if I give you a function f of x as product of two functions, let us say u and v, product of two different functions. In that case, what is the derivative of the function? That is what we want to understand, right? So the rule
Yes, sir.
here is that the derivative of this function is derivative of the first function times the other as such plus the first function times the derivative of the second. Is that clear to you?
Yes, sir.
That is the rule. So this is called the product rule.
Okay, so you alternate with the derivatives, right, sir? One derivative times one non-derivative.
Correct. So I'm giving you overview, a big picture of the whole thing, mainly because tomorrow when your teacher is going to teach you this chapter, they will go through derivatives and all these concepts you will understand
Yeah.
very fast, right? I do not want to teach you the complete chapter,
Yeah.
right? Because I don't want to take away the fun of learning, right?
Right.
We will learn few very key aspects today, and that will help you to understand very easily the chapter, even if you go back and read your book. Is that okay?
Yes, sir.
Now, let me give you the quotient rule also. If my function f of x is equals to u of x, we normally write, okay, you can write u over v, okay, doesn't matter. U of x over v of x. In that case, the derivative of the function is this v of x gets squared. And here we have derivative of ux times denominator minus
Yeah.
ux times derivative of denominator. Do you see that? That is the rule. Is it okay?
Yes, sir.
I will like you to copy both these rules and then we'll look into some questions based on the product and the quotient rules. Okay?
Yes, sir.
So basically, I want you to apply these rules effectively to find the solution. That is the whole idea. So let me erase this. You copied them, right?
Yes, sir. I have it down.
Very good. So we'll stop sharing. I do have another lesson which is based on this concept. So let me see if I can share that with you now. So here's my lesson on product rules. Oh, already. Good.
Yes, sir.
Okay. So these things we have already learned. This is a proof of this derivative. Actually, this is the proof for the product rule. I'm not getting into the proof of the product. This is the proof of the sum rule. You can see
Yeah.
by difference quotient, we will prove it. Not a big deal. You get the idea. You can see how
Yes,
it's
sir.
done, right? So we are not getting
Right.
into this sum, and we have already done all this, right? Now,
Right.
let us find the derivative of the function, right? So we'll take up the questions one by one and try to answer them using the formula learned. So I don't want to show you the answers, so I'm looking for just the questions. Okay. So we'll just keep it like this. You see that?
Yeah.
Correct. So we have question number one right at the bottom, right? Y
Yes.
equals to x minus 2 times 3x plus 5. Tell me, what is the derivative y prime equals to?
Yes, sir. So it would be the derivative of x minus 2
Which
times
is
3x
1.
plus 1.
Which is 1, right?
Yes, which is 1. Right.
So basically, you write like this d dx of x minus 2 times the second function, which is 3x minus 5, plus the first function as such, which is x minus 2 times d dx of 3x plus 5. You get the idea, right?
Yes, sir.
Now, what is the derivative of x minus 2?
0, sir.
1.
Oh, constant. Constant. Sorry, 1. Yes.
Because, see, derivative of x dx
Right.
dx
Right.
is 1, right? So 1. So
Yeah.
this is 1 times 3x minus 5, right?
Yeah. 3x plus 5. Right, sir?
The question was plus 5. Yeah, plus 5. Correct. And then plus x minus 2 times what is, oh, sorry, I did not write x minus 2. Derivative of 3x plus 5 is how much?
Also 1, sir.
3x.
Oh, sorry. Yes. 3. Yeah.
So
Sorry.
now we have what? So it is, uh, this is like 3x plus 5 plus 3 times x minus 2. You can expand, simplify. You get the idea?
Yeah.
3x plus 5, and then uh, you got 3 times x minus 2, which is plus 3x minus 6. And you can
Minus.
simplify, right?
Yeah.
6x minus 1 is your answer. Is that clear to you?
Yes, sir.
So that is how you're going to do it. And as you can see, the answer is same as we got, right?
Yeah.
So here we have shown you all the steps. Do you see the steps?
Yes, sir.
So this writing dy dx is useful because you know what exactly you're doing. So
Right.
first function's derivative, product of the other, plus, so you do plus with derivative of one and then product of the other, and then you
Yeah.
simplify your expression to get the answer. Now we have the next question, which is 2x cube, 2x. Now we have the next question, which is y equals to 2x uh, cube
Yeah.
times square root of x plus 5.
Yes, sir.
So how will you do the derivative of this?
Sir, you would follow the same method, but
Correct.
now you'd have to find the derivative of 2x
2x
cubed,
cube.
which would
What is
be
the derivative of 2x cube?
6x squared.
So multiply this with square root of x plus 5. And now add to 2x cube what? Derivative of square root of x
Uh,
plus 5, right? Which will be
yes,
1
sir.
over 2 square root of x plus 5. With more practice, you'll
Sir,
get it, right? Half
sir,
over, yeah,
can we go over how to quickly find the derivative of root of x plus 5?
sure. So let me just add a page to this, right? No problem.
Yeah.
So let us say we have the function f of x equals to square root of x plus 5, right?
Yeah.
This you think like x plus 5 to the power of half, right?
Half. Yeah.
So the derivative of this function will be half times x plus 5 to the power of half minus 1, which is minus half, right?
Minus half. Right.
So this could be written as 1 over, this 2 is already there, square root of x
Oh,
plus 5.
x plus 5. Okay, got it.
So,
Yeah.
so whenever you have that square root function, it is now
Yeah.
very clear that be half because the exponent is
Right.
half, and then half minus 1 is minus half, and therefore you get
Yeah.
this. Is that clear to you?
Yes, sir.
Right? Very important derivative. And just as I did easily, you could have also done it, and you will now do it. Correct?
Yes, sir.
Correct. So, where were we? Okay, there we go. Perfect. So we've done this question, right? Now we have
Yeah.
3. How does it matter? Even if there are 3, then what we are going to do? So I'll write down another function here, new page. We'll just make our question, right? Doesn't matter.
Yeah.
We are understanding the process, right? So let us say f of x is x cube times, we keep it simple, right? Because we have to
Yeah.
understand the rules, right? We have product of 3 this time, not 2.
Yeah.
Then what should it be? Well, what should be the derivative? Derivative will be find derivative of one of them, multiply the
Yeah.
other two, and then follow this process.
Right.
So in this case, the derivative of the first one is 3x squared,
3x
right?
squared.
Multiply
Yeah.
this with x plus 5 and x minus 3. Now add to this derivative of the second term, which is 3x squared, and this derivative is just 1, correct?
Just 1. Yes.
X minus 3. And now to this, add the derivative of the third one, which is x, sorry, this was x cubed, right?
Yeah.
And then we have x cubed, x plus 5, and the derivative of the last one is 1. And then
1.
you can combine all these terms to get the answer. You get the idea.
Yes, sir.
So it
Got
doesn't
it.
matter if there are many derivatives involved, correct?
Yes, sir.
Now, I'll take up another very important question. So I'm skipping those questions because they're already solved. We can always, I can always send you that over to you. But let's
Yeah.
understand the concepts. So I'm calling another function g of x as, let us say, 2x plus 3 divided by, let us say, 3x minus 5. Now there, how will you find
Yeah.
the derivative? You will use the quotient rule, right?
Yes, sir.
Right. So we will try to do this using both quotient rule and product rule. Can you use product rule to solve this question?
Uh, yes, sir. Because you can flip the division into multiplication, right?
Perfect. So you can write this as 2x plus 3 times 3x minus 5 to the power of minus 1. And therefore,
Yeah.
you can use the product rule also. So,
Yeah.
what is your exercise now? Is use both product rule and the quotient rule and see, do you get the same answer? Just practice, right? Just figure it out.
Yeah.
Yeah, just do it and then tell me.
Yes, sir.
So I've used the product rule and given you a short answer, but I'm not going to use the quotient rule, right? Can you help me
Yes,
use
sir.
the quotient rule? Denominator
Yes,
square.
sir.
See how we use it very easily. Correct?
Yeah.
First thing you should write. Now, what is the derivative of this function? 2, right?
Two, sir. Yeah.
2 times the denominator, which is 3x minus 5 minus, what is the derivative of denominator? 3, right?
3.
3 times the numerator, which is 2x plus 3. Do you get the idea? That is what you get.
Yes, sir.
And now you simplify this, correct? So open
Right.
and simplify. And when you open, you get 6x minus 10 minus 6x minus 9, correct? 6x seems
Yeah.
cancelled, minus 19. So what we get here is minus 19 over 3x minus 5 whole square. And if you calculate this, you see the denominator, then you will probably get the same answer. You get the idea,
Yes, sir.
right? So you could apply quotient rule, or you could apply the product rule in such
Yeah.
case. Perfect. So that
Yes,
is
sir.
kind of a twist to our learning. So we just did this. Okay, great job. Here is the last question for you.
Yeah.
Okay, can you please read the question?
Yes, sir. The number n of new COVID-19 cases per week in Toronto is modeled by the function n of t equals 300t squared divided by t squared plus 1, where 0 is less than or equal to t, t is greater than or equal to 0, which is less than or equal to 8. At what rate is the number of cases changing after 1 week? Apply the
Right.
quotient rule and substitute t equals 1.
Correct. That is the concept, right?
Yeah, that's
Because
the
you were
concept.
given, see how the quotient rule has been applied and how it should be written in the test. So the denominator square, I want you to visualize it. That's the whole idea, right? Because I
Yeah.
know tomorrow when your teacher will teach this subject, you will be practicing from the book also. You will know how to
Yeah.
answer, but visualize. So the derivative is what? First thing, write down the denominator square as I have done, right? So this
Yeah.
t plus 1, do you see I've written that in square? And now
Yeah.
we have to find the derivative of the numerator. So derivative of the numerator, do you see that?
Yes.
Times the denominator, and then you have to do a minus sign, remember,
Minus.
quotient rule, and then we have the first term, but the denominator's derivative, right? So you
Yeah.
write pdt in this case because t is the independent variable. And
Yeah.
you know, 300t squared derivative is 600t, 2 times 300, right? And here
Yeah.
2t is the derivative, and then you can actually simplify the expression. Once you simplify, after that substitute 1 for t, right?
Yes.
Get your answer. Do you understand? And write
Yes, sir.
complete sentence in a word problem as your answer with units so that you do
Yeah.
not lose 0.5 marks just for missing out on units. You
Yeah.
understand that?
Yes, sir.
So, this is an application question on what we learned. We actually covered 2 chapters today. One was the product rule, the other one was the quotient rule. Effectively,
Yeah.
they're one and the same thing, right?
Yeah.
Sometimes, as in this case, you can see very easily. Quotient rule is better to apply, right? We already have a common
Yes. Yeah.
denominator, we have a numerator, neat and clean to apply. But in the test paper, I have seen many times, teachers will say, well, apply the product rule to answer this
Yeah.
question to make it more difficult, right? Challenging.
Yeah.
So that happens, and that is why I had that question for you right in the very beginning. Is it all
Yeah.
clear to you?
Yes, sir. All clear.
Perfect. So now, can you revise or can you tell me what have you learned about the derivatives today?
Yes, sir. So we basically completed the entire chapter today because we finished the product rule, the quotient rule, also the power rule, and then we also revisited all the notations too.
Correct.
So I actually learned a lot today,
Mm.
and I feel like when the teacher actually does teach this topic, I'll be ready now because I know how to apply the product rule and the quotient rule and how they're interrelated and how I can go from one to the other. So I think that'll really help me.
Correct. Now, what you should do is you can go to the YouTube channel, just type out Anil Kumar derivatives playlist and see what you
Yeah.
have. Let's do it, and then I'll tell you which videos to watch. Is it okay?
Yes, sir.
So you can now run your YouTube channel, write down Anil Kumar derivatives
Yeah.
playlist. If you type MCV for you, you'll get questions related to your curriculum.
Yes, sir.
Because I teach globally, students all over the world, but MCV
Yeah.
for you is your Ontario curriculum.
Yes. You can see, right, sir?
Yes, I can. Yes, typo. Oh, you wrote. Okay, so we already did this beautiful lesson on introduction to derivatives and those graphs which show you where
Yeah.
it is not differentiable, cusp, corner, or discontinuity.
Right.
Correct? Move on.
Yeah.
So derivatives of exponential functions you will learn later. MCV for you, calculus, you could check this also. There are many examples, 127, but we'll avoid it
Yeah.
for now. Let's go to the other playlist. Okay. So this is calculus, test derivatives, exponential and trigonometry functions. We are not yet there. Chain rule, we are
Yeah.
not yet there. Please continue. So there are so many playlists which you could do. Practice questions and evaluating limits. That test is already over. That is our last recording, right?
Yes. Yes.
Good job. Next. So likewise, we have chapter 2, calculus. Run this. Yes. So chapter 2 on derivatives, 80 videos above this, 80 videos. This is the one which is for your chapter 2. And I have 80 videos for you from this chapter. Do you read the can you read the titles of the videos here?
Yes, sir. Differentiability concepts and derivatives with first principle. Tangent from external point. Power derivatives application. At what point will normal cross the curve y equals x squared minus 3x plus 5?
Yeah.
Rearranging the function to apply power rule. And
All
more
these
differentiation.
are, Akshay, all these are test questions, very difficult questions from previous test
Yeah.
papers selected. And so many, 80 of them in this playlist. I will like you to click on the second one. And then this is a very beautiful question. And
Yeah.
then we'll discuss that. Okay.
Yes, sir.
Can you please read the question?
Yeah. Find the equation of tangents from 318 to y equals negative x squared plus 6x plus 5.
How will you do it? Tell me.
Yes, sir. So first we can find the equation of the derivative itself,
Okay. Then
right? And then after that, it's asking us to find the equation of all the tangents or just one tangent, sir.
so tangents, what does that mean? So you find this derivative which is minus 2x plus 6. Easy job.
Yes.
Then what will you do? Tell me.
So sir, then if they're asking for all of the tangents from 3 to 18, then you would plug in the points, right? And then
Which point
evaluate
will you plug in?
3 and 18.
Wrong answer. See, you have a hint here, tangents. If I have a graph, this is a parabola, correct?
Oh,
And
yes.
let us say, if I have a point given to me, right, then there can be only one tangent at the given point.
Yeah.
How can I have more than one tangent? Tell me.
Yeah.
How can I have more than one tangent? Tell me. Because it is an external point. Very, very important. Many
Oh, so it's
students
not
get
on the curve?
lost. If you plug in 3, just plug in 3 and find the value of y. Just plug in 3. What do you get? Minus 9 plus
Yeah.
18 plus 5. Right? How much it is?
Yeah.
It is not 18, right?
14. Yeah.
It is 14. So the point is not on the curve. Since it is an
Oh.
external point, we actually get 2 tangents from this point. You get the idea?
Yes, sir.
Because this point 318 is outside the curve. Now tell me, how will you answer? We have an external point 318 and we found the derivative to be minus 2x plus 6. Tell me, How will you answer this question?
Yes, sir. So we know that one derivative is minus 2x plus 6, right?
Mm-hmm.
So if the other derivative is also meeting at that point, then shouldn't they intersect? We can use
Okay.
that concept to
Then
find
no.
the other
How will you
derivative.
answer the question then? You will not be able to answer. So,
Yeah.
Akshay, this is a challenge question. So, the idea here is that you know the derivative is slope of the tangent line, but you don't know this point. So, let this point x value be a. If x value is a, what is the value of y? Y value will be minus a square plus 6a plus 5,
It's
correct?
fine. Yeah.
Now, derivative gives you the tangent. So this equation gives you the slope of the tangent, which is minus 2x plus 6. Now, what is
Yeah.
the slope between these 2 points? You can do y2 minus y1 over x2 minus x1, getting the slope of this line, correct?
Yes, sir.
Equate this to minus 2x plus 6. Is that clear to you?
Yes, sir.
And once you equate, only unknown will be a, right? Actually, if at a the derivative will be minus 2a plus 6, right?
Plus 6. Yeah.
Of course, minus means we are looking into this tangent, right? Okay.
Yeah.
But when you do that, then you can find the value of a. Since it is a quadratic equation, you get two values of a, and therefore you get both the points. You get the idea.
Yes, sir. So quick question. When we did y2 minus y1 over x2 minus x1, right? That was between the initial derivative and then minus a squared plus 6a plus 5, right?
Between the point 3 and 18, because external point to that point, right? You see that tangent?
Okay, to some point a, right?
Yeah, to any point A. Then
Okay.
you can solve this question. So it's a challenge question for you at the moment, and thinking an application question for any test paper on derivatives when it is chapter 2, right in the beginning. You get the idea.
Yes,
Perfect.
sir.
I'd like you
Yeah.
to now move on to almost end of the video so that you can see the answer. No, I mean this video itself, which we're running. There are
Yeah.
many there. Okay. But you can explore my playlist later, right? You
Yeah.
have plenty of examples there. Do you see what I'm showing you here? Do you
Yes,
understand the
sir.
concept, right? So we found the derivative as minus 2x plus 6 and equated with the slope of the line, which is
Yeah.
P2Q or P2R, right?
Right.
And then we had a quadratic equation to solve, which we solved and found two values of A. You get the idea? In this
Yes.
factored form, substituted those values of A to find the Y, and we got the coordinate points on the curve. You get the idea?
Yes, sir.
So whenever you see in a question tangents, that means it is an external point.
External
So you
point.
have to
Yeah.
approach in this fashion, just as we have done in this video. Is that okay?
Yes, sir.
Good job. So we'll end our lesson here today, and I'd like you to summarize our learnings from this short
Yes,
lesson.
sir.
Yes.
So, in overall today we finished an entire test. We covered the two lessons and we also solved challenging problems, which I found really helpful because if I do encounter such problems like we just did, where the point doesn't actually lie on the curve, I wouldn't be able to know what to do. But now I know what to do. So I think that will be really helpful because now I know how to approach the problem as opposed to
Correct.
yeah.
And knowing more and knowing in advance helps to be right on the top of the class as you are. And that is what I wish, right? Be on the top.
Yes, sir.
Okay. Okay, then. Thanks a lot, Akshat.
Thank you so
Thank
much,
you,
sir.
and bye. Thank you. My pleasure.
Bye.